Good evening, kids. In today's class, we are going to discuss the alternating current JEE main previous year questions 2023 January shift. And there are around 12 questions are there. They are based on the basic concepts and the formulas. So once again, the prerequisite means what are the read concepts, revise all concepts. Then memorize all formulas. Then solve PYQ. Okay, these are the three important things which you have to apply. There's no other choice. Then without revising concepts, you can't manage with the formula. Because once you have the clarity of concepts, sir, concept बोले तो क्या है यहाँ पे क्या करना है concept में तो जो भी theory है like register, what do you mean by RMS क्या है RMS current बोले तो क्या है what do you mean by average current RC circuit, RL circuit, RLC circuit, pure resistor, pure inductor, capacitor connect किए तो AC source में current and voltage power dissipations क्या क्या relationship है and series resonance. बाकी this is theory. एक घंटा आप तुम रिवाइज करे तो भी ओके फाइन गुड. देन कम्स फॉर्मुलास. ऑल द चैप्टर्स यू नो, आपको पता है लेके कौन से कॉन्सेप्ट्स हैं. वो जो कॉन्सेप्ट्स है लेके बहुत डेरिवेशंस लंबे रहते हैं, वो सबको तुम डिराइव एग्जाम में डिराइव नहीं कर सकते. अगर तुम फॉर्मूला याद रहे तो easily you can tackle the questions. So these are the things. Next again, if you solve PYQ, आपको पता हो exactly you'll get idea like किस लेवल का प्रिपरेशन मुझे करना चाहिए. So without solving PYQ आप प्रिपेयर कर रहे हो, then again it's a really problematic. हर चैप्टर का प्रीवियस ईयर क्वेश्चन है 100 या 150 क्वेश्चन, करीब करीब आप तुम 50-60 कर लिए तो भी ओके फाइन गुड. नो इन द प्रेजेंट सिचुएशन इससे पहले कर चुके ओके फाइन गुड. लेट मी स्टार्ट दिस क्वेश्चन. एन LCR सीरीज सर्क्यूट, यहाँ पे कैपेसिटेंस है, एक रेजिस्टेंस सीरीज सर्क्यूट में, और उसको AC सोर्स का फ्रीक्वेंसी 2 किलो कनेक्ट कर चुके हैं. करंट मैक्सिमम एम्पलीट्यूड ऑफ करंट फ्लो हो रहा है. देन इज आस्किंग उसका इंडक्टेंस वैल्यू कितना है. आई थिंक वी कैन ड्रॉ द सर्क्यूट. रेजिस्टर, इंडक्टर, a capacitor, AC source. There is a capacitor, inductor, or a resistor है. Across resistor, current and voltage they are in phase. Across inductor, current lags the voltage. So current यहाँ पे same phase में रहेगा, और inductor will have phase angle of 90 degree. Across the capacitor, current leads the voltage. Some small correction. Across the inductor, current lags the voltage. Across the capacitor, current leads the voltage. Okay, this is a phasor diagram. So what do you mean by lead lag? Means voltage when it is high, the current will be low. There's a meaning of this one. When current is high, voltage will be low. There's a meaning. And voltage and current, both what happen will be same. There's a meaning of that particular phase angle. Okay, now he's asking आपको इसका value पूछ रहे हैं. How to calculate that one? Frequency of this will be how much? He has given 2 kilohertz. What do you mean by current? यहाँ पे maximum बोल रहे हैं. तो जो current flow हो रहा है circuit में, ये जो current flow हो रहा है RMS current to the circuit, this is maximum बोल रहे हैं. So when the current will be maximum at resonance. So if you know the basic graph, resonance का ये जो ग्राफ है, फ्रीक्वेंसी का सोर्स जब आप इंक्रीज कर रहे हो, तो जब इंक्रीज कर as frequency of source आप इंक्रीज कर रहे हो, करंट इन द सर्किट विल इंक्रीज, यहाँ पे मैक्सिमम हो जाता है, फिर बाद में डिक्रीज हो, इट स्टार्ट डिक्रीजिंग, डिक्रीज होते जाता है, एंड एट वन फ्रीक्वेंसी, जहाँ पे फ्रीक्वेंसी एट विच करंट इज मैक्सिमम, उसको हम रेजोनेंस फ्रीक्वेंसी बोलते हैं. ओके फाइन. इसका वैल्यू कितना है, रेजोनेंस फ्रीक्वेंसी का वैल्यू कितना है, दैट्स व्हाट वी हैव टू कैलकुलेट. और रेजोनेंस फ्रीक्वेंसी f naught equal to 1 by 2 pi LC. f naught का वैल्यू कितना है, 2 kilos 2000, 1 by 2 pi. L value we have to calculate, 62.5 into 10 to the power of minus 9. Squaring 4 into 10 to the power of 6, 4 into pi square, 1 by सॉल्विंग दिस आपको L का वैल्यू मिल जाएगा. रेजोनेंस फ्रीक्वेंसी का ये फॉर्मूला आपको याद रहना चाहिए बस. At resonant frequency, current will be maximum, and this maximum current is what flowing. Okay, done. There's a basic concept. At resonance, current will be maximum. What is the idea of this problem? At resonance, current will be maximum. There's a basic idea. इस आइडिया के ऊपर ही एक क्वेश्चन हम सॉल्व कर रहे हैं. एंड रेजोनेंट फ्रीक्वेंसी का फॉर्मूला आपको तो पता है, 1 by 2 pi under root of LC. We'll take the next question. A series LCRs connected to AC source. The circuit contains a resistance R equal to 80 ohm, an inductor of inductive reactance. A series LCR circuit is connected to an AC source. The circuit contains a resistance, inductor of inductive reactance, and capacitor of capacitive reactance. The power factor of circuit. वही सेम सीरीज रेजिस्टर, यहाँ पे इंडक्टर और एक कैपेसिटर, तीनों हम सीरीज में across the source we are connecting series. So sir, what do you mean by series? In series, current will be same. The current will have zero phase. There's a current, a voltage. There's a current, this one. So यहाँ पे आप फेजर डायग्राम अगर आप ड्रॉ कर रहे हो, एक करंट का जीरो फेज हो गया, दिस विल बिकम BL, और ए हो गया आपका BC. Then if you rearrange this, if you rearrange this one, this will become, and VRMS, let it be यहाँ पे, this is VRMS. So this voltage triangle, and this will be VR. What is VR? Drop across resistor. What is VRMS? Applied voltage. What is I or IRMS? Both are same. यहाँ से आप VR, VL minus VC, VL greater than VC, let's assume that VL minus VC. Then this will become VRMS. This is the voltage triangle. From voltage triangle, apply the Ohm's law. VRMS equal to kitna? Equal to IRMS into Z. Ohm's law across resistor, IRMS into R. This I only IRMS, the symbol we are rewriting it. VL equal to IRMS XL. VC equal to IRMS into XC. Substituting this and solving, यहाँ पे हमको impedance triangle मिल जाएगा. इसी को क्या बोलते हैं हम? This one is impedance triangle. अगर आपको वोल्टेज पता है, if you know the drop, अगर आपको VR, VL, VC का इंफॉर्मेशन है तो then use this particular voltage triangle. अगर आपको impedance triangle, impedance के बारे में पता है, so we know impedances are XL, XC and R. Then use impedance triangle. I'm giving idea. If you know, अगर क्वेश्चन में वोल्टेज के बारे में कुछ डेटा है तो इन रजिस्टर इंस्टेड ऑफ रजिस्टर, अगर वोल्टेज अक्रॉस ड्रॉ रजिस्टर, वोल्टेज अक्रॉस इंडक्टर एंड वोल्टेज अक्रॉस कैपेसिटर दिए तो use voltage triangle to calculate power factor. What they're given reactance and resistance, so we'll use impedance triangle. So what is the power factor formula? Cos phi is equal to VR by VRMS. Impedance triangle में power factor is equal to R by mod of Z. What is Z? Total impedance of circuit, X square XL minus XC whole square. R का वैल्यू कितना है? 80. R square 80 square. XL minus XC 70 minus 130 whole square. 80 under root of 80 square. So this will be 130 minus 70. 60 square. Solving आपको power factor will become x by 10 will be 8 by 10. It will come 80, 6,400, 3,600 will get 80 by 100. Okay, this one solving आपको under root का value 100 मिलेगा. So this will become 8 by 10. This is our answer. Okay, fine. यहाँ पे कॉन्सेप्ट कौन सा है? अगर इम्पिडेंस डेटा रहे तो यूज दिस पावर फैक्टर कैलकुलेट करने के लिए इम्पिडेंस ट्रायंगल का कॉन्सेप्ट यूज कर लो. अगर आपको वोल्टेज के बारे में डेटा दिए तो देन वोल्टेज ट्रायंगल यूज कर लो. I'll take the next problem. For the given figures, choose the correct option. यहाँ पे आपको only pure resistive circuit is there. is a pure resistor. रजिस्टर के अलावा कुछ भी नहीं है. यहाँ पे रजिस्टर और एक सोर्स भी कनेक्ट कर चुके हैं. यहाँ पे इंडक्टर कैपेसिटर कुछ भी नहीं. तो यहाँ तो आपको प्योर रजिस्टर मिलेगा. दिस इज RLC circuit series. The RMS current in the options directly same ना. आप वोल्टेज देख लीजिए 220 वोल्ट RMS, यहाँ पे भी 220 RMS, सेम फ्रीक्वेंसी. करंट के बारे में इंफॉर्मेशन पूछ रहे हैं यहाँ पे. सो इज आस्किंग अबाउट दिस करंट I1 and I2 and what is this RMS करंट. RMS करंट के बारे में पूछ रहे हैं. कंपैरिजन के बारे में पूछ रहे हैं. First we'll look at the option. What we know, हमें क्या पता है, like what is the in the first figure A circuit में what is our IRMS current? I1 equal to VRMS value, VRMS by R, 220 by 40, 11 by 2, 5.5 ampere. Then what about I2? I2 is equal to VRMS by is asking R square plus XL minus XC whole square. I mean, we don't know XL and XC. Comparison 40 ohm, and we have to check the resonance. Agar at resonance only, what will happen at XL equal to XC, how much I2 equal to? I2 will become equal to VRMS by R. Means at resonance, यहाँ पे अगर resonance हो रहा है बोले तो then RMS का करंट वैल्यू कितना होता है, कितना हो जाता है? VRMS by R. इस फिगर ए सर्क्यूट में या फिगर ए में द आरएमएस करंट वैल्यू कितना कितना हो जाता है? 220 by 40, 5.5 ampere. At resonance only this is possible. At resonance we are writing. No, कैलकुलेट कर लेंगे. सो कितना वैल्यू हो गया आपको? 5.5. और स्ट्रिक्टली एट रेजोनेंस. Resonance means what should be the frequency? Frequency of the circuit should be equal to 1 by 2 pi LC. Circuit, is it in resonance is what we have to check it. पहले हम resonant frequency calculate कर लेंगे. L value 50 into 10 to the power of minus 3 or a 0.5 into 10 to the power of minus 6. ये हो गया आपका 10 to the power of 10, 10 to the power of 5 outside हो रहेगा. बाकी रूट में 250 5 बाहर आ जाएगा. तो 255 10 10 to the power of minus 5, 10 pi into 10 to the power of minus 5 root 10. तो इसका वैल्यू 10 to the power of यहाँ पे 1000 10,000 pi root 10. Pi also approximately pi is 3.14. Root 10 is what? Approximately we can write it as 3. Pi as 3 है. 3 का वैल्यू 3.4 है. रूट 10 का वैल्यू भी करीब करीब अराउंड 3. Let me calculate. Root 10 3.16. 3.14 into 3.16 will be 9.92. Approximately इसको हम 10 कर देंगे. Then how much resonant frequency? Resonant frequency का वैल्यू हुआ now अब कितना हुआ? 1000 हर्ट्ज. फ्रीक्वेंसी का सोर्स का फ्रीक्वेंसी कितना है? 50 हर्ट्ज. Then up what is the conclusion? कब करंट मैक्सिमम रहेगा? Current will be maximum only at resonance. And a maximum current कितना 5.5. Resonant frequency of the circuit कितना? F0 1000 hertz. But what is the frequency of source? 50. So हम जो 50 बात कर रहे हैं, it will come somewhere here. It will come up. आपको यहाँ पे में हो जाएगा. So then what is the current here? यहाँ पे जो current flow हो रहा है, this will be less than that 5.5 ampere, and this is the value of I2. Maximum current is what? 5.5 ampere. At 50 years, What is the current flowing? Will be very less. This will, at resonance, this current will flow. At any other frequency other than resonant frequency, the current flowing in the circuit will be less than 5.5 ampere. This value. बाकी other frequency, जब frequency का source other than 50 रहेगा, other than 1000 रहे, 1000 है, तब कितना current will be less than 5.5 ampere. So what we can write here now? Choose the correct options. पूछ रहे हैं. At resonance, current in B is less than that in A. Wrong, no. At resonance, current in the circuit B and A will be equal. These are wrong. The RMS current in circuit can be larger than that in A. Not possible, no. At resonance only maximum current कितना है? कितना होगा? 5.5. So this is not possible. The RMS current in figure is always equal to that in figure B, no. At resonance only, current in the figure A will become equal to current in the figure B. यहाँ पे तो आपको RMS 5.5. यहाँ पे कितना? At resonance only it will be 5.5. Other than resonance, less than 0.5, 5.5. Okay, then the RMS current in the circuit B can never be larger than. Maximum current in the figure B is possible is 5.5. इससे ज्यादा तो नहीं हो सकता है. So I think this is the one possible option what you can pick up. This is wrong, and this is wrong. He is asking very simplified way. He is asking comparison. एक प्योर रजिस्टर का एक आरसी सीरीज रेजोनेंस का कंपैरिजन, करंट के बारे में कंपैरिजन पूछ रहे हैं. We'll take the next question. Then यहाँ पे an inductor of inductance 2 microhenry is connected in series with a resistance, variable capacitance and AC source of frequency. The value of capacitance for which maximum current is drawn in the circuit. 2 microhenry inductor with a resistance, and यहाँ पे आपको एक कैपेसिटर मिलेगा. Okay, fine. 2 microhenry. रेजिस्टेंस का वैल्यू पता नहीं, कैपेसिटेंस का वैल्यू पूछ रहे हैं कितना फैरेड में. देन फ्रीक्वेंसी ऑफ सोर्स गिवन कितना? 7000 हर्ट्ज. देन द वैल्यू ऑफ कैपेसिटर फॉर विच करंट इज ड्रॉन इनटू सर्किट. यहाँ जो करंट फ्लो हो रहा है, दिस करंट इज आरएमएस करंट. दिस आरएमएस करंट शुड बी मैक्सिमम. व्हाट कंडीशन he has put at resonance, a series resonance का curve, IRMS, and this is the resonant frequency or a frequency of source. Frequency of source का कितना value है? 7 kilohertz. Now a capacitance का value, we can adjust the value of capacitance. इसका कैपेसिटिव वैल्यू चेंज करने पर जब फ्रीक्वेंसी ऑफ द सर्क्यूट becomes equal to frequency of source, then resonance will occur. At resonance what happen? There will be a maximum current. ये जो current flow हो रहा है, this will become maximum. And when do this will become maximum? Here, at resonance. And what is the condition for resonance to occur? At resonance, XL equal to XC. What is the value of XC? XC का value omega L है. XC का value 1 by omega C. So this will become omega square equal to LC. and this will be, we know omega equal to 2 pi hai, 1 by 2 pi under root of LC. Then when the frequency of circuit becomes equal to resonance frequency, then resonance occurs. So what is the frequency of source? 7000. 1 by 2 pi. L ka value 2 into 10 to the power of minus 6. Capacitance is what we have to calculate. Okay, now we'll square it up. 7 square into 10 to the power of 6 is equal to 1 by 4 pi square by 2 into 10 to the power of minus 6 into C. थोड़ा बहुत कैलकुलेशंस आपको यहाँ पर 10 to the power of 6 या 10 to the power of 6 दोनों कैंसिल हो जाते हैं. देन यहाँ पे आपको 7 स्क्वायर into 4 into pi square 22 by 7 whole square. Capacitance value 1 by 7 square 4 square 22 by 7 whole square into 2. Solving 1 by x value. This everything will become 3872 farad. What is the concept, sir? What is the concept? Concept to at resonance, inductive reactance must be equal and opposite to capacitive reactance. When the net reactance should be 0, so then only what happens, the current will be maximum. We'll take the next question. In a series LR circuit, XL equal to R, power factor is P1. If a capacitor of capacitance C with XC equal to XL is added to circuit, the power factor becomes P2. The ratio of that. LR circuit draw कर लेंगे पहले. This is the resistance. This is the inductance. AC source यहाँ पे हम कनेक्ट कर चुके हैं. Inductance का reactance XL है, and this is R and VRMS. Added to the circuit. यहाँ पे तुम little bit careful से पढ़ना है. A capacitor of capacitance with X equal to XL is added to circuit. The power factor. दूसरा circuit बना लेंगे. This is a resistor, inductor. एक capacitor series में connect करते हैं हम. Resistor, inductor, capacitor. इसका वैल्यू कितना है? XL, this is XC and this is R. Power factor, and what is the condition given? XL equal to R. What is the power factor? Directly यहाँ पे आप impedance triangle draw करो. R, XL, this is Z1. Then XL equal to XC. So what is the value of, यहाँ पे आपको tan phi1 equal to cos phi1. Power factor formula is cos phi1 equal to R by Z1. R. What is Z1? The impedance of this circuit will be root of R square plus XC square. Sorry, XL square. XL equal to R. There's a condition given. So this will become R root 2. So this will become R root 2. 1 by root 2. Pi 1 equal to, this will become pi, only cos phi 1. He is asking cos phi 1 value. Then यहाँ पे will draw the impedance triangle. A series RLC circuit का impedance triangle draw कर लेंगे. This will be XL minus XC. इसका value resistance R है. The phase angle of circuit pi 2. and let the impedance इसका भी Z2. But what is the condition given? XL equal to XC. This idea is very, very important. Then we'll write down Z2 is equal to impedance of RLC circuit का R square plus XL minus XC whole square. This is the impedance of the series RLC circuit. And this is the impedance of the RL circuit. Okay, agreed. Huh? Then RL square. What is the condition given? XL equal to XC. So bracket में तो 0 हो जाएगा. But this X equal to XC is given. Substituting XL equal to XC here, the bracket term will become 0. Then this will become only R impedance का. Then what is the power factor? Second diagram में, second impedance triangle में, यहाँ पे कितना power factor? Cos phi equal to adjacent by hypotenuse. So R by Z2, R by R. इसका तो power factor 1 है, यहाँ पे तो 1 by 2 है. The ratio of P1 by P2. Power factor becomes P2. So cos phi 1, cos phi 2, 1 by 2 by 1. Power factor is indicating this symbol P1 and this is P2. Power factor becomes P2. Power factor is P1. You should not get confused. यहाँ पे confused मत नहीं होना. P1 means not average power dissipated. Power factor तो E is instead of calling cos phi 1 इसको एक symbol दे रहा है P1. P1 यहाँ पे is not average power dissipated. Power factor का एक symbol define कर चुके हैं P1. यूजुअली हम क्या कि लाइक एसी सर्किट्स में पावर बोले तो पी से इंडिकेट करते हैं. पावर फैक्टर को एक सिंबल डिफाइन कर चुके हैं P1. इन द फर्स्ट सर्किट पावर फैक्टर इज P1. सेकंड सर्किट पावर फैक्टर इज P2. लिटिल बिट बच्चे यहाँ पे थोड़े कंफ्यूज हो जाते हैं. तो P1 मींस एवरेज पावर डिसिपेटेड. नो, P1 मींस हियर पावर फैक्टर इज चेंजिंग सिंबल. यूजुअली पावर बोले तो वी गो फॉर एवरेज पावर. No, यहाँ पे power बोले तो is telling P1 means cos phi 1. Got the idea? Little bit alert. I think is confusing through symbols here. Little bit very good question. Is asking about the RL circuit and RLC circuit comparison. So, see, in every AC circuit, what you have to draw? First, draw this particular phasor diagram. After drawing that, so what you can do? You can try these things. Current and voltage. They'll be in phase across resistor. Across inductor, current lags the voltage. Since they are in series, current यहाँ पे same phase रहना चाहिए. यहाँ पे current का कितना है? Magnitude is high, 0 phase. Then as they are in series, current should be same. It should have same phase and same magnitude. So therefore, we are assuming current of I and phase angle 0. And across inductor, current lags the voltage. So therefore, VL leads the current. Across the inductor, again, you can draw the same similar diagrams. I, VR. Then here will be I, VL. This will be I and this is BC. Across inductor, current lags the voltage or voltage leads the current. Across the capacitor, current leads the voltage. And across the resistor, current and voltage will be in phase. This is about the phasor diagram. From phasor diagram, voltage triangle. From voltage triangle, impedance triangle. From impedance triangle, you can find out the impedance. You can find out the power factor. We'll take the next question. In the given circuit, RMS value of current through the resistor R. यहाँ पे कितना current flow हो रहा है? Is asking you to calculate RMS current. तो हमें तो यहाँ पे आरएमएस वोल्टेज सोर्स का भी दे दिया दिया है, एंड इंडक्टिव रिएक्टेंस कैपेसिटिव रिएक्टेंस आर। सर हाउ टू, कहां से शुरू करना है? यू हैव टू गो बैक टू द कॉन्सेप्ट। You have to go back to the concept. Then impedance triangle draw करो तुम. If you draw the impedance triangle, आपको ए तो Z, this will be XL minus XC. करंट के बारे में पूछ रहे हैं हम. Then we know RMS. Then if you apply the Ohm's law for a circuit, VRMS equal to IRMS into Z. This is the Ohm's law for the total circuit. Ohm's law across resistor, IRMS into R. Ohm's law across inductor, IRMS into XL. Ohm's law across capacitor, IRMS into XC. Now what is asking? Only this RMS value. And we know VRMS. VRMS कितना है? 200 root 2. अब हम impedance find out करेंगे. Then we'll get the IRMS value. Then how to calculate the impedance? Directly from this triangle. What is Z equal to? R square plus XL minus XC whole square. Shall I tell you one simple trick here? In AC circuit, all are vectors. There's a very beautiful way in AC circuit. All quantities must be treated as a phasor. Phasor means will have magnitude and direction. This is called direction ही what we are calling this direction को ही हम यहाँ पे phase बोल रहे हैं. Okay, fine. Mechanics में this direction we diffuse by angle. Here they have some definite angles, not arbitrary angle between 0 to 360 degrees. That particular angle, what we'll call phase. So even the current, voltage, resistance, impedance, inductance, everything you have to treat like a vector, and you are doing this vector addition. Got it idea? There's one trick. You can't write यहाँ पे आप VRMS, VR, VL. How they are again the voltages. Again, you have to take the vector sum of voltages. Since they are series, current will be same, and vector sum of the impedances. Okay, fine. यहाँ पे हम calculate करेंगे. R का value 100 square, XL minus XC 200 minus 100 whole square. So 100 root 2 इसका impedance हो गया. Then we'll substitute in this formula. इस formula में substitute करेंगे. VRMS 200 root 2. Impedance का value कितना है? Impedance calculated 102, and the Z is IRMS हमें कैलकुलेट करना है. इम्पीडेंस वैल्यू कितना कैलकुलेट कर चुके हम? 100 रूट 2. तो IRMS is equal to 2 ampere. This is our answer. This is the golden thing in AC circuit. All quantities must be treated as a phasor. Phasor means, loosely speaking, vectors. Vector addition of resistance, reactance, impedance, vector addition of voltages. Parallel में vector addition of currents. This is one basic funda which you have to observe. These things is what you have to observe. Okay, fine. Next question. In an AC generator, rectangular coil of 1000 turns. Rectangular coil बोल रहे हैं. Okay, this will be the rectangular coil. बहुत सारे अराउंड 1000 टन. मैं कुछ 2 3 4 5 दिखा रहा हूं. इसका एरिया डिफाइन कर रहे हैं 14 into 10 is rotated, इसका 100 टर्न्स है, तो what is the value of number of turns? 1000. Area value 14 into 10 to power of -2 meter square, rotated about an axis perpendicular to uniform magnetic field. Perpendicular to uniform magnetic field. यहाँ पे मैं I'll show the axis. This is the axis. We'll rotate. Look at this value rotated at 360 revolutions per minute. RPM वैल्यू कितना RPM दे चुके हैं. इसको will simplify it. Omega equal to 360 RPM. 1 revolution 2 pi. 1 minute 2 pi radian. 1 minute is 60 seconds. So this will become 12 pi radians per second. I think थोड़ा ये यूनिट आपको अलर्ट रहना चाहिए. If they give RPM, इसको आप रेडियंस में कन्वर्ट करके then you can use it in formula. Agreed? Then magnetic field का वैल्यू कितना है? 3 Tesla. What is the formula for what is the flux linking? Flux linking equal to BS cos theta NBS. Differentiating this d phi by dt NBS cos theta, इसको further up will simplify it. NBS cos omega t. So this will become NBS omega sin omega t. Cos omega t. Differentiation of cos omega t will become minus of sin omega t. Then how we define EMF? Minus d phi by dt. This will become NBS omega sin omega t. क्या पूछ रहे हैं यहाँ पे? मैक्सिमम वैल्यू ऑफ द ईएमएफ प्रोड्यूस. दिस इज द ईएमएफ प्रोड्यूस. इसका मैक्सिमम वैल्यू दिस वन. सो इफ यू फर्दर सिंप्लीफाई दिस, ओके एग्री दिस दिस द कॉइल ई मैक्स. ई मैक्स का वैल्यू कितना? NBS ओमेगा. नंबर ऑफ टर्न्स कैपिटल N 1000. B का वैल्यू 3. एरिया 14 into 10 to power of -2. And omega value is 12 into pi. Pi का value, so this will be यहाँ पे आपको 1030 14 मिलेगा. 10 to power of -2 here 100. You will get cancel out 12 and 22 by 7. Calculate कर लो, आपको करीब करीब around 1584 approximate will get answer. So this is some AC generation. There's a coil. When you rotate this coil about this axis, flux linking the coil changes. Rate of change of flux will be EMF induced, and it will vary sinusoidally. And this will be the maximum value. So यहाँ पे maximum value NBS omega. Number of turns magnetic field, area of cross section of coil, and omega. The symbol A or S. S is area of cross section. सर यहाँ पे एरिया बोले तो दिस टोटल एरिया ऑफ द कॉइल. Okay, done. Then next question: an alternating voltage source is connected across a pure inductor. Pure inductor. Okay, यहाँ पे हम ड्रॉ कर लेंगे इंडक्टर सर्क्यूट. दिस इज अ सोर्स. सोर्स का सिग्नल वैल्यू कितना है? 260 साइन ऑफ 628t. इंडक्टर का वैल्यू 5 मिली एम्पियर. प्योर इंडक्टर इसमें आपको रेजिस्टर या कैपेसिटर कुछ भी नहीं रहता है, ओनली इंडक्टर. इसको हम प्योर इंडक्टर बोलते हैं. इंडक्टिव रिएक्टेंस के बारे में पूछ रहे हैं. What is the inductive reactance? XL should be equal to, what is the value? XL should be equal to omega L. Omega कहाँ पे है omega? This, if you rewrite V naught sin omega t, this omega is 628. L value कितना है? 5 मिली एम्पियर. 628. 628 is what, like 2 into 314 into 5 into 10 to the power of a minus 3, और इसको तुम 3.14 into 5 10 to the power of minus 2, 5 into 10 to the power of minus 3, 10 to the power of minus 2, 10 to the power of plus 2. 314 को 3.14 लिख के you can bring 10 square, 10 square, 10 to the power of minus 3, 5 2 will cancel out, we'll get 3.14. सिंपल है. आपको यहाँ यहीं पे थोड़ा बहुत ध्यान देना चाहिए ना. So what is the 628? 628 is what? Omega. Agreed? This 628 is what? The omega. The angular frequency of the circuit. And this is a maximum value. The inductive reactance is equal to omega. Sir, inductive reactance, what it will do? ये क्या करता है ऐसा? Like, it will control the flow of current and it will make the current to lag the voltage by 90 degree. Then what about IRMS? Can you calculate IRMS? VRMS by XL. VRMS value कितना है? 260 by root 2. XL value we have calculated 3.14. Then you can calculate even IRMS. What about the average power dissipated? 0. What is the inductor? It's the storing element. It will not dissipate power. Huh? Sir, dissipate बोले तो this is a storing element. यहाँ से source से energy लेके it will convert into magnetic energy. Again it will return back. Resistor वैसा नहीं. Resistor what happen? It will dissipate. It will take energy and it will not return back. Inductor what happen? यहाँ से energy लेके फिर return कर देता है. So this is called like a average power dissipated is 0. Small idea, sir. Okay, I'll take the next question. A series LCR circuit contains R, XL, and XC. The input voltage is given. The amplitude of current in the circuit. Series RLC circuit, inductor, capacitor, resistor, capacitor और inductor. यहाँ पे हम AC source given, इसका maximum value Vs equal to 2500 cos of 100 pi t. R का वैल्यू 80 ओम है. कैपेसिटेंस का XC वैल्यू दे चुके हैं, X इक्वल टू 40 ओम. XL का वैल्यू 100 ओम. यहाँ पे एम्पलीट्यूड ऑफ करंट इन द सर्किट. एम्पलीट्यूड बोले तो क्या है? इज आस्किंग अबाउट द मैक्सिमम करंट. What we can calculate? We can calculate IRMS or directly, you know maximum voltage, then you can calculate directly the maximum current. I think थोड़ा बहुत confusion रहेगा यहाँ पे. So sometimes maximum current at resonance, that is different. That is the maximum value of IRMS. Here यहाँ पे amplitude of current पूछ रहे हैं. So we have to get this IRMS value. Then बाद में उसका amplitude value will calculate. Then what is the formula? The general formula will be IRMS equal to VRMS by R square plus XL minus XC whole square. IRMS we can define like this, IM by root 2. VRMS का वैल्यू कितना है? VM by root 2 whole divided by R square का वैल्यू R 80 square XL 100 minus 40 whole square. Root 2 get cancels, under root 2 ये दोनों cancel हो जाएंगे. So this IM is what we should calculate. VM, sir, what is VM? You can rewrite इस equation को cos, आपको यहाँ omega means 100 pi, VM means 2500. So हमें VM value पता है, that is given is 2500. यहाँ पे लगा दो तुम 2500. Under root का value 80 square, 100 minus 40, 60 square. So 2500. So this will be, I think, 10 square. Hundred will come. Root of 80 square plus 80 square will be 100. Then 0 निकाल देने पर this current will be 25 ampere. You should not get confused. Even at resonance, हमें पता है कि like current will be maximum. ये वाला करंट IRMS का मैक्सिमम रहता है यहाँ पे. ओके फाइन सर, लगे कहीं ये तो नहीं पूछ रहा है दिस मैक्सिमम करंट इज व्हाट इज बीइंग आस्क्ड? नो, एम्पलीट्यूड ऑफ करंट. अगर इसके बारे में पूछ रहे बोले तो देन यू विल कॉल इट एज मैक्सिमम करंट इन द सर्क्यूट. आई थिंक देयर इज अ डिफरेंस इज देयर, एम्पलीट्यूड ऑफ करंट एंड मैक्सिमम करंट. मैक्सिमम करंट इन द सर्क्यूट व्हेन इट विल अकर जब सर्क्यूट रेजोनेंस में हो, मींस frequency of source equal to resonant frequency of circuit, then the current here will be maximum. The RMS value of current will be maximum. He's asking this amplitude. This is called like an amplitude. Better not call this as maximum current, call this as amplitude of current. Terminology. In books, I think they never called this as maximum current. They called amplitude only. If you calculate IRMS, then its amplitude will be Im by 2 or I naught by root 2. We have some simple math, the following one. Math the list one में क्या है? AC generator. AC generator works on what? Electromagnetic induction. Fine. AC generator में what is AC generator? AC generator में आपको कॉइल रहेगा, कॉइल रेक्टेंगुलर और सर्कुलर. इसको हम घुमाएंगे मैग्नेटिक फील्ड में, अगर घुमाए तो इसको, एंड यहाँ पे आपको मैग्नेटिक फील्ड, देन EMF विल बी इंड्यूस्ड एंड इसको E नॉट sin ओमेगा t. Flux linking the coil equal to BS cos omega t. Differentiating this minus NBS, differentiating this NBS omega minus sin omega t. This minus है. Then इसको E equal to minus d phi by dt, Faraday's law. Then NBS omega Fine. This is about the generation. No? What is this? This is a Faraday's law. The concept based on electromagnetic induction. EMI is what we'll call. So AC generation कैसे होता है कि like if you take the coil and if you rotate in a magnetic field, then only EMF will be generated. Okay, fine. हम ये कर लेंगे. This is the then transformer. Transformer आपको पता है like it works on the inductor, mutual inductance. यहाँ पे आपको प्राइमरी कॉइल, ये सेकेंडरी कॉइल, यहाँ पे हम वोल्टेज लगा देंगे, प्राइमरी वोल्टेज और एंड प्राइमरी करंट. यहाँ पे आपको सेकेंडरी वोल्टेज एंड सेकेंडरी करंट, म्यूचुअल इंडक्टेंस will occur. A varying flux flowing in the a varying current flowing in the primary will induce current in the secondary. So some sort of mutual inductance will take place between the coils. So therefore, the basic idea of the transformer is what? Mutual inductance. Transformer, mutual inductance. Then resonance phenomena to occur. What do you mean by resonance? Resonance ka, I'll write it EMI. In series circuit only the resonance will take place. XC, this is XL, this is R, and at resonance current will be maximum. Then for condition, XL must be equal to XC. What is XC? Omega L, and this is omega C. अगर इंडक्टर कैपेसिटर दोनों सर्किट में रहे तो ही इट विल बिकम रेजोनेंस. अगर कैपेसिटर नहीं रहेगा देन इट विल बिकम आरएल सर्किट, नो रेजोनेंस. अगर इंडक्टर नहीं रहे तो देन विल बिकम आरसी सर्किट एंड वहां पे रेजोनेंस कुछ फिनोमिना ही नहीं रहेगा. देन रेजोनेंस के लिए क्या चाहिए? इंडक्टर एंड कैपेसिटर मस्ट, बिना रेजिस्टर भी रेजोनेंस हो जाएगा. बट रेजोनेंस के लिए व्हाट इज द कंपलसरी? इंडक्टर एंड कैपेसिटर दोनों रहना चाहिए. बिना रेजिस्टर भी रेजोनेंस सर्किट बन सकता है अगर इंडक्टर कैपेसिटर रहे तो. कंपलसरी क्या है? इंडक्टर कैपेसिटर. आई थिंक विल टेक दिस ऑप्शन. रेजोनेंस फिनोमिना के लिए कंपलसरी इंडक्टर और कैपेसिटर चाहिए. Sharpness of resonance. So this particular thing, जो sharpness है ना, it depends upon like a resistance. Or say what you say, quality factor. Quality factor depends on what? Depends upon R, omega, and L and R and C. This part is deleted. This is not there for present, not there for JEE main 2025. I'm making things clearer. You need not to bother. Sharpness of resonance. It depends on what, like quality factor. So since not there, no, let's not waste time. But therefore JEE advanced. It is there for JEE advanced 2025. Okay, done. Next question ले लेंगे. A series LCR circuit is connected to AC source. 220 volt. The circuit contains a resistance R and inductor of inductive reactance. The capacitance are needed to maximize the average rate at which energy is supplied. What is the meaning? Meaning needed to maximize the average rate at which energy is supplied, means power supplied should be maximum. When power supplied is maximum in a RLC circuit at resonance, this is the inductor, here capacitor, this is the resistor. When source will supply maximum power, 220 volt, 50 hertz. This is a source. XL value, XC का value पता नहीं. R given 1000 ohm. The capacitance of capacitor is asking C value. But हमें कितना में what are the values given? XL value given. कितना 79.6 ohm. When there will be maximum transfer of energy at resonance? At resonance, the power dissipated in the circuit will be maximum. And this is resonance. Okay, fine. इसको RMS current indicate कर दो. At resonance, the current will be maximum, and here only the power dissipation maximum. So what is the resonance? The maximum transfer of energy will take place from source to the circuit, and who will accept this maximum energy? The resistor. And for resonance to occur, what is the condition? XL must be equal to XC. Okay, that one. So here XC should be equal to XC. XL का value कितना है? 790.6 ohm. XC value is asking C value. XC will be 1 by omega C. Omega is 2 pi f. 1 by 2, 3.14. फ्रीक्वेंसी कितना दे चुके हैं? कितना दिया है? 50 हर्ट्ज. ये सब्स्टिट्यूट कर लो. So C is equal to 1 by 2 into 3.14 into 50 into 79.6. We have to microfarad में पूछ चुके हैं. If you do calculation, इसका 2 into 3.14 into 50 into 79.6. 24994 करीब करीब आ रहे हैं. 24994.4. इसका रेसिप्रोकल ले लेंगे. This reciprocal का value 0.0040. 4 zeros के बारे में 4 zeros है यहाँ पे. So this will become 40 microfarad. Okay, fine. This is a key. So what's the concept? This is the idea. Question पढ़ते ही, like if this idea flashes for you, this is the basic idea. Fine. This is the idea of the problem. This is a background. अब concept को भी revise करने के बाद ये थोड़ा background concept should be there. Then at resonance, the current will be maximum, and because of maximum current flowing, maximum power dissipation. ये maximum power dissipation across resistor हो रहा है. इसके लिए इसको कौन energy supply कर रहा है? This particular source. This is a background concept. But in exam, with this background concept, you must have this particular at resonance x equal to xl and x equal to 1 by omega c, this basic formula. Okay, then I'll take next question. Okay, I think okay, we have completed. Okay, kids, like we have discussed the 2023, the January shift. You can see all the basic formulas are there. So what all we have the formulas: XL equal to omega L, inductive reactance 1 by omega C. Then average power dissipated, VRMS, IRMS cos phi. Power factor formula R by Z. Agree this Ohm's law across each element. IRMS into XL, VC equal to IRMS into XC. VRS equal to IRMS into R. देख लो ये सभी formulas हैं and at resonance XL equal to XC and power factor equal to 1. Average power dissipated IRMS square by R. Then we'll dissipate the maximum, we'll dissipate power in the AC circuit, only the resistor. What do you mean by dissipation? The electrical energy को it will convert into heat energy. That's called it a dissipation. Inductor capacitor वो भी energy ले लेते हैं source में. Then they'll convert into magnetic field and they will return back. तो इसलिए हम inductor capacitor को energy storing elements बोलते हैं. So what are inductor capacitor? L and C. They are storing elements. They don't dissipate power. यहाँ पे कौन dissipate करता है? Only the resistor. So then you know Ohm's law. Sure. Then this phi is called as a phase angle of circuit. The best thing is like read this chapter. Read once. Read once instead of spending here and there watching that. No need of any inspiration. किसी का इंस्पिरेशन वीडियो का देखने का जरूरत नहीं. जस्ट वही 1 घंटे टाइम में आप एक चैप्टर पढ़ लो. At least it will help you to solve one problem. So stop watching all unnecessary videos which are other than physics, chemistry, maths. Simple rule. It's a golden rule. कौन सा भी टीचर रहने दो, जेई मेंस का जो भी टीचर है पढ़ा रहे, तेरी वॉच कर लो, जो अच्छे से तेरी पढ़ाते हैं तेरी कर लो. तेरी इज इनफ. वहां से तेरी तुम फॉर्मूला इकट्ठे कर लो, प्रीवियस मीन्स जाके तुम कर लेते जाओ बस. दैट विल इंक्रीज योर कॉन्फिडेंस. Any teacher, either advanced teacher, mains teacher, even the board exam teacher, the one who are teaching the CBSE board or state boards, there is enough. What all they teach theory, that is more than enough for JEE means. Any teacher will teaching all the fundamentals, basics which are there in the NCERT book. Listen those teaching, learn from them. उन टीचर से तुम पढ़ लो, बस अपना फॉर्मूला से याद रख लो, जाके जेई मेंस प्रीवियस करो. दिस इज मोर देन इनफ. इससे ज्यादा मैं कुछ एडवाइस दे नहीं सकता हूँ, बिकॉज व्हाट इज इंपॉर्टेंट टू सॉल्व द प्रॉब्लम्स इन एग्जाम्स. फर्स्ट, reading question. What are the basic ideas? So you should read the question. So first thing is first, what are the essentials for exam? Essentials for JEE means first reading question. जब आप क्वेश्चन पढ़ रहे हो, लिटिल बिट यू हैव टू बी केयरफुल. लैंग्वेज रीडिंग क्वेश्चन में व्हाट ऑल यू हैव टू मेक ऑब्जर्वेशन. लैंग्वेज और नथिंग बट हम keywords we say. Make observation of keywords. The keywords what happen will decide the idea of the problem. Then which topic it belongs, a question कौन सा topic का है, then what is the idea involved, what formula यहाँ पे तुम लगा सकते हो, what is the unknown thing, क्या find out करना है. I think all these methods are needed. First was reading question and observing keywords. Keywords के बाद में then okay कौन सा chapter का है, कौन सा सब topic का है, then what is the idea involved, what is asking, unknown thing, then next the formula, then high speed calculations, then cross checking. These are the essentials for JEE Mains. Then जब read करने के बाद तुम्हें पता है ना this topic, then if you are not prepared that topic, you have to say goodbye to the question. And कुछ फिजिक्स ऐसे टॉपिक्स है जहाँ पे क्वेश्चन देखते ही आपको टॉपिक का याद आ जाता है. लाइक सपोज थर्मल एक्सपेंशन, कोएफिशिएंट ऑफ थर्मल एक्सपेंशन कांस्टेंट्स डिफाइन करते हैं. सो इमीडिएटली आपको अल्फा, यू नो अल्फा, कोएफिशिएंट ऑफ थर्मल एक्सपेंशन, सो दिस बिलोंग्स टू थर्मल एक्सपेंशन. अगर यंग्स मॉडुलस दिया तो दिस इलास्टिसिटी. अगर एन मोल्स ऑफ गैस वहां पे इंडिकेट कर रहे हैं क्वेश्चन में, तो दिस क्वेश्चन बिलोंग्स टू केटीजी और थर्मोडायनामिक्स. अगर स्टीफेंस कांस्टेंट, वीन्स कांस्टेंट है, देन दिस टॉपिक बिलोंग्स टू रेडिएशन. अगर चार्ज, इलेक्ट्रोस्टैटिक्स, समथिंग magnetic field, electromagnetic induction or electromagnetism, capacitance, capacitor circuit, resistor circuit or RC circuit, atomic physics, find the wavelength, atom. So the question में ही आपको जो टॉपिक, कौन सा टॉपिक को एक क्वेश्चन बिलोंग है बोलकर द डेटा, द कांस्टेंट्स will help you. Okay, fine. So coming okay, next video, okay, we'll discuss in detail what are the methods for JEE Mains, everything. Okay, thank you all of you kids. Yeah, bye. All the best. Do prepare well. Morning kids. We are going to discuss about the JEE Mains previous year questions. So we'll start with the alternating current. Alternating current is a very small chapter where every year one question, and that way a simple formula based. So, and I request every student, like there are some 6 or 7 formulas are there, and effectively it will take just 1 hour to revise this chapter. Please do revise. Listen first all the theory, understand all the concepts. 7 or around 10 formulas are there. Daily for 5 or 2 minutes, revise them. Practice few previous year questions from around 20, 30. That'll be sufficient. Definitely can manage any question coming from this. So we'll start with the, let me discuss, and as we proceed, I will give the proper guidance rather than simply giving guidance may not help you. As and when the question comes, what method, how to prepare a given chapter, I'll be helping you. Please do say this. So this complete series I'm going to complete. Every chapter, the previous mains will be uploaded. Parallelly, guidance will be given. Okay, now first we'll start with the alternating current, JEE Mains previous year 22 April shift. Okay, there's a one question I picked up. There are two statements are there. An AC circuit undergoes electrical resonance if it contains either a capacitor or an inductor. First, we'll check the statement one is right or wrong. So we know, like this is the basic diagram for electrical resonance. So there must be a resistor, capacitor, and inductor, and an AC source. So this is C, L, R, and this is the frequency. And the resonance frequency of this circuit depends on 1 by 2 pi under root of LC. Okay, I agree this. This will be your resonance frequency. Then look at this, the resonance frequency depends on what all? Resonance frequency depends on L as well as C, no? L as well as C. I'll write it clearly. It depends both on L and C. Both must be there. Capacitor should be there and inductor should be there. Then only it can be resonance. But he's telling either. Either means या और या कैपेसिटर नहीं तो इंडक्टर कौन सा भी रहे तो रेजोनेंस नो इट्स नॉट लाइक दैट दोनों चाहिए यहाँ पे इंडक्टर कैपेसिटर दोनों रहे तो देन उसको रेजोनेंस बोलते हैं हम ओके लिटिल बिट हिंदी आई नो आई विल ट्राई टू मैनेज इट तो इलेक्ट्रिकल रेजोनेंस के लिए इंडक्टर कैपेसिटर बोथ रहना चाहिए सर्किट में अगर कोई एक रहे तो इट्स नॉट एन resonance. It will become RC circuit, RL circuit. Then it will not become resonance. Fine. So this statement 1 is wrong. Sir, what is actually resonance? Resonance में क्या होता है? Resonance, what will happen? There will be a transfer of energy from the source to the load. When the frequency of source, there will be a transfer of energy from source to the load. When the frequency of the source becomes equal to resonant frequency of the circuit. In a very simple, at resonance, energy transfer source से circuit को ज्यादा पहुंचता है. Means maximum transfer of energy occurs. कहाँ से? From source. So what is the source? We will supply it. So this will supply energy. Supplies energy. What about resistor? Accepts energy. So what do you mean by resonance? Transfer of energy from source to the circuit. जब रेजोनेंस हो रहा है बोले तो क्या होता है कि यहां से एनर्जी मैक्सिमम ट्रांसफर सर्किट को हो जाता है. दैट पर्टिकुलर फिनोमेना विल कॉल रेजोनेंस. ओके फाइन. उसके लिए कैपेसिटर और इंडक्टर दोनों रहना जरूरी है. फाइन. ओके नो. सो देयरफॉर द स्टेटमेंट 1 इज रॉन्ग. Then statement 2. An AC circuit containing a pure capacitor, pure inductor consumes I power due to its non-zero power factor. AC circuit containing pure inductor, pure capacitor. What do you mean by pure? शुद्ध बोलते हैं ना. मीन्स उसमें ओनली कैपेसिटर, कुछ रेजिस्टेंस कुछ भी नहीं, अगर नहीं रहे तो उसको विल से प्योर. दिस इज सोर्स एंड दिस इज कैपेसिटर. यहाँ पे रेजिस्टर कुछ भी नहीं रहना चाहिए, ओनली कैपेसिटेंस एंड नेक्स्ट इंडक्टर. So then it's telling high power. High power means ज्यादा power consume रहता है. It's very simple. Who will consume power? Only resistor will consume power. This is a basic idea. You write it clearly in AC circuit. I'll write this basic instruction. In AC circuit, only resistor consumes power. Resistor is the only one which will consume power. What about capacitor? Capacitor क्या है कि like it will accept energy and will return back. Inductor also will accept energy, will return back. It will not consume power. Capacitor will not consume power. Inductor will not consume power. Consume अलग है यहाँ पे. कैपेसिटर क्या करता है कि यहां से एनर्जी ले लेता है फॉर क्वार्टर साइकिल. अगेन क्वार्टर साइकिल में एनर्जी रिटर्न करता है. अगेन नेक्स्ट क्वार्टर साइकिल इट विल यहां से ले लेता है सोर्स से और ए रिटर्न दे देता है. व्हाट इज द नेट एक्सेप्ट किया कैपेसिटर मींस नेट एनर्जी टेकन बाय कैपेसिटर. कैपेसिटर कितना ले लिया? जीरो. सिमिलरली इंडक्टर सोर्स से एनर्जी ले लेता है फिर रिटर्न दे देता है. अगेन इंडक्टर अगेन विल टेक इन वन साइकिल अगेन विल रिटर्न बैक. दो बार एक्सचेंज होता है एनर्जी बिटवीन कैपेसिटर सोर्स, बिटवीन इंडक्टर एंड सोर्स. सो नेट क्या हुआ? सो इट्स वेरी सिंपल. 10 joules ले लेता है, 10 joules रिटर्न कर देता है, 10 joules अगेन इट विल टेक, अगेन इट विल रिटर्न बैक. तो नेट नेट जीरो. रजिस्टर वैसा नहीं है. रजिस्टर क्या है कि लगे कंटिन्यूसली एक्सेप्ट करते ही लेता है. सो इट विल कंटिन्यूसली एक्सेप्ट द एनर्जी ऑफ द रजिस्टर. वी से डिसिपेट. डिसिपेट मीन्स खा लेता है. थोड़ा आई नो सम लिटिल बिट हिंदी, मे बी यू शुड ट्राई टू अंडरस्टैंड. मीन्स इट विल कन्वर्ट इलेक्ट्रिकल एनर्जी इनटू हीट एनर्जी. डिसिपेट मीन्स ओवर. एक बार दिया तो रिटर्न नहीं आता है. तो एक बार जब सोर्स एनर्जी रजिस्टर को दे दिया तो रजिस्टर क्या करता है, उसको वो इलेक्ट्रिकल एनर्जी को हीट एनर्जी में कन्वर्ट कर देता है. So it will not return back. This is what the dissipation means. कैपेसिटर में क्या होता है कि लगे इट विल टेक एनर्जी फ्रॉम द सोर्स, इलेक्ट्रिकल एनर्जी को, उसको इलेक्ट्रोस्टैटिक फील्ड एनर्जी में कन्वर्ट करता है. फिर अगेन इट विल कन्वर्ट बैक इलेक्ट्रिकल एनर्जी इनटू द सोर्स एनर्जी, इलेक्ट्रिकल एनर्जी. इंडक्टर इट विल टेक इलेक्ट्रिकल, यहां से इलेक्ट्रिकल एनर्जी लेके यहाँ पे मैग्नेटिक फील्ड एनर्जी में कन्वर्ट हो जाता है. अगेन मैग्नेटिक फील्ड एनर्जी विल बी कन्वर्टेड बैक टू द इलेक्ट्रिकल एनर्जी. सो यहाँ पे नेट पावर कंजम्पशन बाय इंडक्टर विल बी जीरो. मीन्स लेन देना है. यहाँ पे लेना है देना है, लेना है देना है. यहाँ पे क्या है कि ओनली रजिस्टर लेना है. लेना है को व्हाट वी से द डिसिपेशन. प्लीज डू एडजस्ट विथ माय हिंदी बिकॉज मोस्ट ऑफ देम रिक्वेस्टेड सर थोड़ा बहुत हिंदी में पढ़ाओ. सो आई एम ट्राइंग ए लॉट. If you are not comfortable with Hindi, just put comments. Okay, I'll stop it or I'll try to improve it. Please do share your feedback. So what is the conclusion? No, both the statements are wrong. Both the statements wrong. So we'll pick up the third statement. Both the statement 1 and 2 are false. Okay, fine. It's very good question. Sir, इसके लिए like what is the method? Sir, like ऐसे questions हम कैसे प्रिपेयर कर सकते हैं? इट्स वेरी सिंपल ना. फर्स्ट आपको पढ़ना चाहिए ना. ये इधर उधर उधर वीडियो देखो तो कुछ भी फायदा नहीं. सीधा जाके तुम एसी सर्किट ले लो, पहले थ्योरी पढ़ो. अभी भी तो कितना 50 दिन 50 दिन बाकी है. एवरीडे 1 चैप्टर रिवाइज. 30 दिन में हो जाता है कंप्लीट. तो रिवाइज ऑल थ्योरी, देन डेली रीड फॉर्मूलास, then solve previous year Q. That'll be more than enough. Unnecessary, don't waste time seeing this, that. Read the theory, understand it, revise all formulas, finish off. No need to watch any of the videos. Directly, you're going to get a better rank. Okay, kids, we'll take the next question. Given below are two statements. When the frequency of AC source in a series LRC circuit increases, the current in the circuit first increases, attains a maximum value, and then decreases. See, reading question very important. It's a skill which you have to develop. Means we have to be alert. LCR, okay, LCR series circuit, something related to resonance. In a series LCR circuit, the value of power factor at resonance is 1. So directly we will take help of the resonance phenomenon. Resonance, you should remember, ये सर्किट तुमको याद रहना चाहिए. रेजोनेंस में सोर्स और रजिस्टर, इंडक्टर, कैपेसिटर तीनों सीरीज में रहते हैं. और सिलेबस इज ओनली सीरीज रेजोनेंस. पैरेलल रेजोनेंस नो नीड टू प्रिपेयर. आई विल गिव इंस्ट्रक्शन. पैरेलल रेजोनेंस no need to prepare. Prepare only series resonance. This is a part of syllabus. Fine. तो रेजोनेंस में क्या है कि दिस इज द सोर्स, यहाँ पे सोर्स और रजिस्टर, इंडक्टर, कैपेसिटर तीनों सीरीज में रहते हैं. फाइन. ये तुमको याद रहना चाहिए सर्किट. देन वी हैव वन कर्व. यहाँ पे आपको एक रेजोनेंस का कर्व मिलता है. फ्रीक्वेंसी वर्सेस रेजोनेंस, करंट वर्सेस, एक करंट वर्सेस का फ्रीक्वेंसी एक कर्व रहता है. तो पहले एज फ्रीक्वेंसी इंक्रीजेस करंट इंक्रीजेस. एक फ्रीक्वेंसी के पास करंट मैक्सिमम होता है, हो जाता है. सो दैट विल कॉल इट एज रेजोनेंट फ्रीक्वेंसी. फाइन. Then what is that resonance frequency? उसका फॉर्मूला क्या है? 1/2 pi अंडर रूट ऑफ LC. Agreed? This is the formula for. यहाँ पे जो रेजोनेंस, जब रेजोनेंस अगेन अगेन सेम कॉन्सेप्ट. रेजोनेंस में क्या होता है? एट मैक्सिमम, एट रेजोनेंस, ए सोर्स है ना, दिस विल सप्लाई एनर्जी टू सर्क्यूट. ये सर्क्यूट को एनर्जी देता है. यहाँ पे कौन लेता है एनर्जी? द रेजिस्टर. हु विल डिसिपेट एनर्जी? द रेजिस्टर. व्हाट अबाउट इंडक्टर, कैपेसिटर? दे विल नॉट डिसिपेट एनर्जी. ओके फाइन. जब भी रेजोनेंस होता है, तो रेजोनेंस मीन व्हाट एक्चुअली हैपेंस? द फ्रीक्वेंसी ऑफ सोर्स, the frequency of source when it becomes the frequency, resonant frequency of circuit. Resonant frequency of circuit किसके ऊपर डिपेंड होता है? इंडक्टर एंड कैपेसिटर. The L and C. This is L and this is C. Agree this? सोर्स का फ्रीक्वेंसी हम चेंज कर सकते. सो आई एम ये सोर्स का फ्रीक्वेंसी मैं इंक्रीज कर रहा हूं एट वन पर्टिकुलर फ्रीक्वेंसी ऑफ सोर्स. जब फ्रीक्वेंसी ऑफ सोर्स becomes equal to resonant frequency of circuit, then current in the circuit will be maximum, the total current. Fine. So here the current which is flowing, ये जो current है, this is RMS current, and this current will be maximum at resonance. And उसके बाद this will be an impedance curve. This will be impedance का, एक current का. Okay, agree this? So at resonance, current will be maximum when the frequency of AC source increases. The current in the circuit first increases, maximum attains maximum value. यहाँ पे maximum हो जाता है, फिर बाद में decrease हो जाता है, then decreases. Okay, statement 1 is correct. Fine, this is correct. Then we'll come forward. In a series LCR circuit, the value of power factor at resonance is 1. What do you mean by power factor? Power factor का, we will draw a triangle, impedance triangle. Impedance triangle, this is R, this is XL minus XC, and this is Z. यहाँ पे आपको 3 ट्राइंगल मिलेंगे एसी में. एक वोल्टेज ट्राइंगल, इंपिडेंस ट्राइंगल और एक पावर ट्राइंगल. हम जो बात कर रहे हैं आप नाउ इंपिडेंस ट्राइंगल प्लॉट कर रहे हैं. दिस इज कॉल्ड लाइक इंपिडेंस, दिस इज रेजिस्टेंस, दिस इज कॉल्ड लाइक ए रिएक्टेंस. So how you define power factor? Power factor cos phi is equal to R by mod of Z. R by. So what is the value of Z? Z equal to कितना? Impedance का A हो गया XL minus XC whole square. This is the formula for impedance. No? Then at resonance, what happens? At resonance, जब resonance हो रहा है सर्क्यूट में, XL will become equal to XC. इसी फॉर्मूला से this equation got derived. Agreed? So then at resonance, the value of Z कितना होगा? R, because XL minus XC will become 0. So Z equal to, now Z equal to R, it will become, substitute here RZ. Then how much power factor? Power factor equal to 1. Cos phi को we are giving a better name. इसको एक अच्छे नाम से बुला रहे हैं, power factor. At resonance is 1. So power factor का value कितना हुआ? 1. So this statement 1 is correct. So both statement 1 and 2 are true. And then, so you look at the, so like a statement 1 is correct, but statement 2 is true. So A नहीं होगा. Statement 1 and 2 are false. This is not it. Statement 1 is correct, but statement 1 is false. तो यहाँ पे दोनों सही है. So we take the key 3. I'll take the next question. Again. As per the given graph, choose the correct representation of curve A and B, where X equal to reactance of pure capacitive circuit connected with AC source. XL is reactance of pure inductive circuit connected with AC source. R equal to impedance of pure resistive circuit connected with AC source. R, impedance of LCR series circuit. यहाँ पे हम 3 सर्किट प्लॉट करेंगे. Okay, यहाँ पे so now we will plot the different circuits. Impedance x एक्सिस में, y एक्सिस में क्या है? इम्पीडेंस है. यहाँ पे आपको इम्पीडेंस है. x एक्सिस में क्या है? फ्रीक्वेंसी. और ये जो कर्व दिखा रहा है, सो एक कर्व है, कर्व ए, और दूसरा एक कर्व भी है. कौन से एलिमेंट्स को ये रेफर हो जाता है? मीन्स एक कर्व है, इंडक्टर है या कैपेसिटर है या रेजिस्टर है. कर्व भी इंडक्टर है, कैपेसिटर है या रेजिस्टर है. आई थिंक यही पूछ रहे हैं. और इम्पीडेंस. व्हाट इज द फॉर्मूला फॉर दिस वन? प्योर कैपेसिटर. यहाँ पे कैपेसिटर हम कनेक्ट कर लेते हैं. देन XC इक्वल टू how much it is? 1 by 2 pi FCM. अगर तुम इंडक्टर कनेक्ट कर लिए तो XL equal to 2 pi FL. सर ये XC क्या होता है? What is the meaning of XC? XC is the reaction. Reaction is different than resistance. Reaction में क्या होता है कि phase angle introduce हो जाता है voltage और current में. There will be some phase angle will be introduced between the current and voltage. In the resistance open, there will be a opposition to the flow of current. Whereas in the reactance, what it will do? It will introduce some phase angle and also decrease the flow of current. Resistance will only decrease the flow of current. What about the reactance? It will decrease the flow of current and also will introduce phase angle. Capacitive reactance, what it will do? It will make the current to lead voltage. Inductive reactance, it will make current to lag the voltage. Resistor, current and voltage will be increased. Okay, these are the problem. Next, again, one more resistor ka le lenge. So this is the resistor source. Then here also current will flow, and what is the current? Current I equal to V by R. So as voltage increases, current will increase. Next, iske baad is telling there is a LCR circuit also. A inductor है, यहाँ पे inductor, capacitor, resistor, and this is the source. No, all the values. यहाँ पे current, impedance, we will say the impedance. Impedance बोले तो कितना? Z equal to R square XL minus XC whole square. इसके बाद what is Z is equal to? Z further यहाँ पे हम लिख सकते हैं Z equal to R square. XL कितना? 2 pi FL. XC कितना? 2 pi FC. ये जो प्लॉट है, हम what is this plot? First we'll identify. A capacitor, तुम देख लो, capacitor as a frequency increases, capacitance reactive capacitance should decrease, no? Reactance, this will call reactance, capacitive reactance. Frequency increases, reactance should decrease. And a जो equation है, this will represent rectangular hyperbola. So curve A will represent capacitive reactance. Okay, fine. यहाँ पे A है ना, X. Okay, fine. Then afterwards, यहाँ पे ले लो XL, inductive reactance. It directly increases with frequency. अगर frequency increase हो रहा है तो inductive reactance will increase and directly proportional straight line passing through origin. I think this particular graph will satisfy. और यहाँ पे तुम frequency increase करो, resistance will not change. Resistance is independent of frequency, whereas XL and XC depends on frequencies. Impedance depends on frequency. तो tell me like आप कौन सा ऑप्शन ले लेते हैं? ये तो एक कर तो कैपेसिटिव रिएक्टेंस का इक्वेशन सेटिस्फाई हो रहा है और बी इक्वल टू एक्सएल एक कर्व भी तो इट इज सेटिस्फाइंग द इंडक्टिव रिएक्टेंस का इक्वेशन सेटिस्फाई हो रहा है. सो देयरफॉर ऑप्शन डी वर्टन और ऑप्शन 4 विल पिक अप. दिस विल बी आवर करेक्ट ऑप्शन. सो की विल बी 4. तेरी तेरी आपको आपको पढ़ना है यार. यू हैव टू रिवाइज. कुछ भी नहीं, नथिंग, वेरी सिंपल. एसी सर्किट ओपन कर लो बुक और पढ़ो बस. जस्ट बेसिक्स. व्हाट डू यू मीन बाय रेजिस्टेंस, व्हाट डू यू मीन बाय इंडक्टिव रिएक्टेंस, व्हाट डू यू मीन बाय कैपेसिटिव रिएक्टेंस, ये आरसी सर्किट क्या होता है, आरएल सर्किट क्या होता है, देन व्हाट डू यू मीन बाय इंपेडेंस. जस्ट समझ लो यार. स्मॉल स्मॉल थिंग्स है. ये समझने के बाद देन टेक द प्रॉब्लम्स. अपने आप खुद कर सकते हो तुम. नो नीड ऑफ एनी मोटिवेशन, नथिंग. डोंट वेस्ट टाइम हियर एंड देयर वाचिंग दिस एंड दैट. Start reading. That's all. Finish or no other. Very simple. You want rank, read it. Reading is the only thing which will help you. Inspiration, oh, either, huh, will not work. जितना भी इंस्पिरेशन ले लो, बिना 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 ये फॉर्मूला, बिना इसका इसका कॉन्सेप्ट, इसका आइडिया से क्या तुम एक क्वेश्चन कर पा सकते हो? कोई तो भाई रहने दे यार. Let him, whoever the best person will inspire you. You cannot solve this problem without knowledge. So for exam, what is essential? Knowledge is essential. Knowledge कहाँ से आता है? पढ़ने से आता है. सब पढ़ रहे हैं फिर भी बोल रहे हैं. There is a natural. हम पढ़ रहे हैं बोलने के लिए. So पढ़ते जाओ 2-3 बार, अपने आप प्रॉब्लम्स करते जाओ. थोड़ा 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 याद याद हो जाता है तुमको. Fine. So you have to prepare things. So we'll take the next question. No. Fourth question. Maximum power is displayed in circuit containing an inductor, capacitor, and a resistor connected in series with an AC source when resonance occurs. Maximum power is displayed in circuit containing pure. Okay, पहले statement का. Second statement का maximum power is displayed in circuit containing pure resistor due to zero phase difference between current and voltage. Directly we will draw statement 1 का एक circuit ले लेंगे. This is the is telling यहाँ पे आपको इंडक्टर है, एक कैपेसिटर है और एक रेजिस्टर है. दिस इज सोर्स. यहाँ पे L, C and this is R. When resonance occurs, this is a curve. Okay, fine. And this is a current का है. And this is the x-axis will be resonance frequency. And this is a resonance frequency. Resonance frequency depends on what? 2 pi under root of LC. Maximum power is dissipated. Power dissipation depends on what? Who will dissipate power? Only the resistor will dissipate power. Then what is the power dissipation? That depends upon current. And we know already the basic concepts. Power factor will be maximum at resonance, no? And how much here equal to power factor? Equal to 1. And at resonance, what is the average power dissipated formula? Or in general, in AC circuit, there is a formula. VRMS equal to IRMS cos phi. Agreed? At resonance, what is the power factor? Equal to 1. So VRMS, IRMS into 1. Or VRMS equal to IRMS into R into IRMS. So this is IRMS square R. At resonance, what is the maximum power dissipated equal to IRMS square, and at resonance current will be maximum. So definitely the power dissipation is maximum. So therefore this statement 1 is correct. Maximum power is dispensed circuit containing pure resistor due to zero phase difference between current and voltage. यहाँ पे हम और एक सर्किट ले लेंगे, एक रेजिस्टर, प्योर रेजिस्टर मींस यहाँ पे इंडक्टर कैपेसिटर कुछ भी नहीं रहता, ओनली सोर्स एंड रेजिस्टर. देन यहाँ पे करंट IRMS. So power dissipation, applied voltage VRMS. What is the power dissipated? VRMS into IRMS. And apply Ohm's law, VRMS equal to IRMS into R. So kitna hua now? IRMS square into R. So this is the average power dissipated. And what is voltage and current? They'll be in phase. अगर आप तुम across register का curve ले लो, this is the voltage, this will be the current का curve, and both will be in phase. A O VRMS and A O current curve. And if you check it, both are in phase. Both are in phase. So therefore now, यहाँ पे भी maximum power dissipation will be there. Okay, agree this. So this statement also correct. So what will pick up? Option 2 ले लेंगे. Agree this. एक what he has done is यहाँ पे series resonance का concept statement 1 है. Statement 2 में he has directly asked about the pure inductor connected to AC source. Then who will dissipate power? Only resistor. यहाँ पे भी कौन dissipate करता है? Only resistor at resonance. कैपेसिटर इंडक्टर पावर ही नहीं डिसिपेट करता है, दे डोंट डिसिपेट एनी पावर. यहाँ पे जो भी डिसिपेशन होता है वो रेजिस्टर वजह से होता है. एग्रीड सर. लाइक फाइन सर, लाइक ए मैक्सिमम पावर का आप जस्टिफिकेशन कैसे करते? मैक्सिमम पावर डिसिपेटेड इन सर्किट कंटेनिंग प्योर रेजिस्टर ड्यू टू जीरो फेज डिफरेंस बिटवीन करंट एंड वोल्टेज. ये थोड़ा बहुत लिटिल बिट ambiguous we can say, because कब आप मैक्सिमम बोलते हैं? जब वो इंक्रीज डिक्रीज हो रहा है. Then but we know what is the at all the time what is the power? IRMS square. Is it like that? No. Instantaneous power will be increasing and decreasing. Agreed? Instantaneous power hai, it will vary with the time sinusoidally. Then he's asking about that maximum power. Fine. In exam, I think it's all about you have to think just to with a simple basic idea, sir. You should not confuse yourself. Sir, what is maximum power? यहाँ से सर ओके मैक्सिमम पावर यहाँ पे है, पावर डिसिपेशन इंक्रीजेस बिकम मैक्सिमम देन डिक्रीजेस. ओके सर, इसको मैक्सिमम. यहाँ पे सर आप कैसे जस्टिफिकेशन करते हैं? मैक्सिमम पावर, द एवरेज पावर, ओके फाइन, कांस्टेंट, but instantaneous power in pure resistor circuit will be varying with the time, and at one instant will be maximum. I think justified, no? Okay, fine. Maximum negative सोचना बंद करो. Maximum think positively. Maybe out of 25 question, one question may be error, that too like out of like a 5 or 6 shift, maybe what happened 1 or 2 questions out of 6. So not like in every paper 10 questions will be error, not like that. So definitely what happened, we should mold our thinking so that we should not think negatively. Unnecessary what happened, you should not think negatively and lose marks here. We'll take the next question. Okay, like a kids, like if you're not comfortable with the Hindi, please do message in the YouTube so that what happen, I'll carry on with the English. Or if you are comfortable with the Hindi, little bit here and there, English, what you can call Hindi plus English, I'll continue. Hmm? With the time, I'll try to improve. But if you are not comfortable with this Hindi, added little bit added Hindi in English, no, so you can just comment it. For next video, I'll see that I'll stick on to only Hindi, only English. Fine. Hmm? I'm just doing experiment. Hmm? Now we'll take the fifth question. A series combination of resistor 100 ohm, inductor of inductance 1 ohm, 1 Henry, and capacitance is connected to an AC source. The quality factor of the circuit will be. Yeah, little bit some. There is no necessity for you to draw the diagram. मैं आप लोगों को explain understand होने के लिए diagram डाल रहा हूँ. बाकी आप एग्जाम में डायरेक्टली विथ फॉर्मूला से have to start thinking. यहाँ like this is the IRMS, this is the VRMS, what we applied. It's asking power factor. Power factor impedance triangle draw करो. This is a series LCR series circuit. XL minus XC, this is a power, this is impedance. I think this is an impedance triangle. Then power factor हम यहाँ पे ऐसे डिफाइन करते हैं, cos phi is equal to R by mod of Z. The quality factor. Quality factor, I think it's deleted for the JEE means. There's a 2003, but 2004 they've deleted. So for JEE means what happened for 2004, I think it's not available. There's a 2003, so therefore it has come. Okay, let me. I thought power factor, quality factor push in. What is the formula for quality factor? Where do quality factor will come? Series resonance में. Fine. So with the help of quality factor, what we can calculate the resonance phenomena in a very systematic way. No, the quality factor. This will resonance curve. Let this be RMS current और a frequency, जैसे resonance frequency. यहाँ पे आपको bandwidth मिलेगा. This is F naught. This is a bandwidth. These are cutoff frequencies, F1 and F2. Quality factor, we can also define this as quality factor. Symbol quality factor का symbol Q है. So this is what typical standard symbol we use. This is defined as resonance frequency by bandwidth, or F naught by delta F, or F naught by F2 minus F1. अगर तुमको यहाँ graphical question कुछ मिलेगा तो take help of this. So there is nothing called any frequency information. Fine. F naught we know it. हमें F naught पता है. So what is F naught? F naught equal to how much? Resonant frequency of circuit 1 by 2 pi under root of LC. So हमें F naught पता है. Bandwidth we don't know. Okay, that we can F2 minus F1. This called as upper cutoff. This called lower cutoff. Okay, this bandwidth we have another alternative formula. Quality factor is also defined as 1 by R root of L by C. Directly formula is there, substitute value of R 1 by 100. Inductance 1. Capacitance कितना 6.25 into 10 to the power of minus 6. So यहाँ पे तुम 1 by 625 10 to power of 8. 10 to power of 400 into 25. Okay, calculation. Then this will become 24 it will be. इसका कुछ यूनिट नहीं रहता है. So this is a deleted for deleted syllabus or deleted topic. Quality factor not there. Deleted topic for JEE main 2025. Finish, okay? So no need to bother. Just straight away now, there's no need to do any experiment. Just say goodbye to this topic. It will come in series resonance. Okay, next we'll take the an oscillating LC circuit consists of 75 milliamp inductor and 1.2. The maximum charge is 2.7. The maximum current in the circuit will be. I think this is based on LC oscillations. So आपको थोड़ा याद दिला दूं. This is the inductor. Initially यहाँ पे charge Q0 minus Q0 capacitance N. Maximum charge हमें पता है. So he's asking the maximum current. At one instant, the current through the inductor circuit will be maximum. Okay, fine. So what is the expression for this current? I is equal to omega root of Q naught square minus Q square. SHM का formula similar to that. X equal to, the formula will be X equal to omega root of A square minus X square. Then maximum current is asking. Maximum current will come when Q is 0. Current will be maximum. Then this will become omega Q naught. What is omega? Omega value. Omega will be 1 by root LC. Okay, fine. So directly omega will be 1 by root LC, and this is equal to Q naught. Q naught value 2.7 into 10 to power of minus 6. Root LC. L will be 75 into 10 to power of minus 3. 1.2 into 10 to power of minus 6. Solve this, will get maximum current will be 9 milliampere. Is asking 9 milli यहाँ पे है, so यहाँ पे 9 रख दो. So what is this concept for LC oscillations का? It is little bit EMI, electromagnetic induction chapter also it is related. From there only this topic has come. The frequency of oscillations. यहाँ पे charge and current will be oscillating, and the equation for charge will be Q equal to Q naught cos omega t. Current का equation Q naught omega sin omega t, where omega equal to angular frequency of oscillation 1 by root LC. Then the charge and current will oscillate, will vary harmonically with the time. And there's a one formula, sir. A very simple question. If you know the theory and no formulas, then you can solve. Otherwise, not possible. Once again, read LC oscillations. Just small idea. The charge and current will oscillate. What is the basic idea of this one? Charge and current will oscillate in circuit. Based on that particular basic formulas, it is being asked. Directly, you should have known that maximum current. Maximum current, when do it occur? When Q equal to 0. I wrote it, and I'll write it here. When Q equals 0, the current will be maximum. And okay, fine. This will happen when Q equals 0. Maximum current. Okay, fine. Symbols. Okay, take the next question. The capacitance of capacitor 150 micro is connected to an alternating source of EMF, the maximum value of current in the circuit. Directly basics यहाँ पे capacitor. This is the source. So source क्या है? Like a maximum value का source 36 sin और angular frequency कितना है? 120 pi t. Capacitance का value भी पता है हमें. So 150 microfarad. Is asking यहाँ पे maximum current. So what is the expression for a current? Ohm's law. Apply Ohm's law. We are going to use Ohm's law. What is the Ohm's law for capacitor circuit? Voltage drop across capacitor equal to current into XC. Fine. Across inductor का formula will be VL equal to I into XL. Across resistor का I into R. This is very important. Just basic Ohm's law. Ohm's law अगर only inductor रहे तो voltage drop across inductor equal to RMS current into XL inductive reactance. Only resistor रहे तो Ohm's law VR equal to voltage drop across resistor equal to current into resistor. अगर यहाँ पे only capacitor है, then the Ohm's law will be I into XC. What is I? Current through the capacitor. What is XC? The reactance. So what is further XC? XC क्या होता है? Capacitive reactance. It will decrease. It will control the flow of current. यहाँ पे जो current flow हो रहा है उसका value XC के ऊपर depend होता है. Then it will make current to lead the voltage. यहाँ पे तुम if you draw the vector diagram, phasor diagram, current leads the applied voltage. This is what V है. यहाँ पे जो हम voltage apply कर रहे हैं, this will become parallel. यहाँ पे parallel because the source is connected across the capacitor. The source is connected across the capacitor. So यहाँ पे जितना भी drop है वो यहाँ पे हो जाता है. It will come here the drop. यहाँ पे 10 volt है. Suppose say 36 volt है. यहाँ पे कितना drop होता है? 36. Then this drop will become, because this will vary with the time, when the drop becomes 20 volt across source, then across capacitor also वही 20 volt रहता है, because they are connected parallel. यहाँ पे कितना drop है at any instant of time, उतना ही drop capacitor में रहता है at any time. Fine. Now what is XC? XC is equal to, the formula for XC will be 1 by 2 pi FC. Sir, what is F? F is omega equal to कितना? 120 pi. So omega 2 pi F. तो कितना फ्रीक्वेंसी आपको 60 Hz. Or you can also write X equal to 1 by omega C. Omega is this one. Omega is this one, 120 pi. And हमें C value भी पता है. Then we can search for maximum current. Okay, then what is V? V का equation यहाँ पे है 36 sin of 120 pi t. Current XC value will be 2 pi or say omega C ले लो. Then this will be I equal to 36 omega C sin of 120 pi t. कौन सा वैल्यू यहाँ पे मैक्सिमम? दिस क्वांटिटी विल कॉल इट एज मैक्सिमम. नो, इसको ही हम मैक्सिमम बोलते हैं इक्वेशन. because when sin 120 pi t becomes equal to 1, अगर a complete this one becomes equal to 1, then जो current flow हो रहा है, then this is the maximum current. So what is the maximum current equal to? Maximum current यहाँ पे आपको 36 omega and C. 36 omega value यहाँ पे है 120 pi. Capacitance का value 150 into 10 to power of minus 6. 10 to power of minus 6. यहाँ पे एक 0 है, यहाँ पे एक 0 है. So like a 10 to power of minus 4. Again 12 into 36. everything we can simplify it. The maximum value of current in the circuit is approximately पूछ रहे हैं. You have to do calculation. 15 into pi will be 3.14. Pi का value approximate 3.14 या 3 भी ले सकते हैं. It will come 36 into 12 into 3 into 15 into 10 to the power of -4. This will come approximately. You have to, यहाँ पे तो आपको कैलकुलेशन करना ही पड़ता है एग्जाम में. There's no other choice. So this will come 19440 into 10 to the power of 4. 1.944 will come. This will be approximately 2 ampere. यहाँ पे यहाँ पे indicate कर रहा है ना, वो like approximately पूछ रहे हैं. So not like exact 1.94, we can approximate to 2 ampere. This will be correct option. Sir, इतना calculations JEE means बहुत सारे प्रॉब्लम है यहाँ पे. आपको मल्टीप्लिकेशन, एडिशन, डिवीजन, सब्ट्रैक्शन, एडिशन, यू शुड बी वेरी वेरी फास्ट. यहाँ पे ट्रांसफार्मर का क्वेश्चन है. एन आइडियल ट्रांसफार्मर with purely resistive load operates at 12 kilovolt on the primary side. It supplies electrical energy to a number of nearby houses at 120 volt. The average rate of energy consumption in the houses served by the transformer 60 kilowatt. The value of road resistance, resistive load RS required in the secondary circuit will be. Transformer. Okay, now यहाँ पे हम सर्क्यूट ड्रॉ कर लेंगे. ऑपरेट्स ऑन द प्राइमरी साइड. यहाँ पे प्राइमरी का वोल्टेज कितना है? 12 किलो वोल्ट. एग्जाम में इस डायग्राम पर जरूरत नहीं. ऑल दिस आपके दिमाग में इट्स बी देयर. इट्स बी देयर इन योर माइंडसेट. Imagination should be there. And this is the resistive load, RL. The value of also served by the transformer 60 kilowatt. Transformer का power कितना है? 60 kilowatt. Then here it will have some primary current. Here यहाँ पे आपको secondary current. यहाँ पे voltage drop कितना चाहिए आपको? 120 volt. Then in transformer, the power in the primary should be equal to secondary, and this is the secondary voltage, and this is the primary voltage. Fine. The resistive load required is asking to get the value of this. There's a one basic circuit. We'll apply the Ohm's law. यहाँ पे जितना भी सेकेंडरी का ड्रॉप है वो सब यहाँ पे रेजिस्टर के में आ जाता है, because they are in parallel. No, the drop across this secondary, it will drop across the resistor. What all the drop across secondary, what when it will appear parallel, it will appear across this load because they are connected parallel. This one is a secondary. And this one is primary. And this is called like a load, resistive load. And we know in the transformer, power of primary should be equal to power of secondary. Then if they ask you anything, VP into IP, this should be equal to VS into IS. Agreed. Then we know what is the power, 60 kilowatt. Is asking to get the value of RL. So then the power in the secondary should be equal to IS square RL or BS square by RL or equal to VS into IS. हमें क्या चाहिए? RL, because see, we can you can also find out IS. I think this will become lengthy. Jara, you have to be alert here. What is unknown thing? आपको रेजिस्टिव लोड के बारे में पूछ रहा है. How much is the resistive load? आपको क्या क्या यहाँ पे इंफॉर्मेशन है? We know secondary voltage 120 volt. And secondary power also we don't know. We know it. तो which formula to be used? अगर आप ये यूज कर रहे हो, then we don't know IS. Again, you have to calculate first IP, then IS, then this one. Lengthy, no? That way, I think this formula will be more suitable. This formula will be more suitable. Let me use that one. This will be PS equal to what is the power? This will be 60 kilo. BS kitna 120 square. Then RL. RL equal to 120 into 120 by 60 into 10 to the power of 3. 12 into 12 into 6 into 10 to the power of minus 2. 6 1 ja, 6 2 ja. Then this will become 24 into 10 to the power of minus 2 ohm or 240 milli ohm. Transformer, very, very, very simple. कुछ भी नहीं, just you have to, आपको ये सर्क्यूट याद रखना पड़ता है. ट्रांसफॉर्मर विल ओबे द लॉ ऑफ कंजर्वेशन ऑफ एनर्जी प्रिंसिपल. यहाँ पे जितना भी पावर है वो सेकेंडरी को, यहाँ पे जितना भी प्राइमरी में पावर है, इट विल गेट ट्रांसफर टू द सेकेंडरी. फिनिश श्योर. देन यहाँ पे स्टेप डाउन ट्रांसफॉर्मर, लाइक व्हाट वी आर डिस्कसिंग यहाँ पे. सो स्टेप डाउन ट्रांसफॉर्मर क्या होता है कि लाइक VS विल बी लेस देन VP. यहाँ पे देखो VP कितना है, 12 किलो वोल्ट है. स्टेप डाउन में 120. स्टेप डाउन अगर वोल्टेज घट रहा है, कम हो रहा है, स्टेप डाउन from 12,000 volt it has become 120 volt, so this will become step down transformer. What is the step up transformer? Step up transformer में यहाँ पे कम वोल्ट रहता है, यहाँ पे सेकंड में ज्यादा रहता है. Agree this? और what about current? प्राइमरी में करंट, स्टेप डाउन ट्रांसफॉर्मर में प्राइमरी में करंट कम रहता है, सेकंड में ज्यादा रहता है. These things try to make observation, very important. A small topic, 2 formulas are there. Okay, fine, you can manage it. We'll take next question ले लेंगे. Okay, this completes your JEE mains. कौन सा shift का? April shift का. So these are the questions that are asked in the April shift. Yeah. So this completes your April shift 2023. Alternating current. देख लो तुम्हें कितना फॉर्मूलास, वेरी सिंपल 6 और 7 फॉर्मूलास आए. इसी के ऊपर सभी फॉर्मूलास रिवॉल्व हो रहा है. जस्ट ओनली हैव टू रिवाइज दिस फॉर्मूलास, नथिंग इज देयर. So once again, I'm requesting to all students, please, like kids, पहले तुम पढ़ो, एक बार 2 बार पढ़ो, फॉर्मूला याद करो, आके प्रीवियस मीन्स सभी करने का जरूरत नहीं, just last 2-3 years. Okay, there'll be sufficient. Now time both coming, or select some each and every one topic, one question. You do it like that. You have to revise. Fine. Okay, now tomorrow I'll bring the April shift. This one will take the 2023. The January shift will discuss the problems. Okay, thank you all of you.